It happens in a fraction of a second. A sudden loud noise in the dark, a car swerving into your lane, a stranger stepping out from an alley, a dog lunging at you. Every part of your conscious mind screams at you to do something, to run, to fight, to yell, to move out of the way. Instead, you do nothing. You lock up. Your muscles tighten, your breath stops, your voice catches in your throat, and for one agonizing second, you stand completely still. Almost everyone has experienced this, and almost everyone feels the exact same way about it afterward, ashamed. We tell ourselves we panicked, we think we failed, we call it cowardice. We wonder why we didn't have the instinct to run or fight when it mattered most. But what happened to you in that moment was not cowardice. It was not a failure of your nervous system. It was an ancient, highly sophisticated survival program taking control away from you to save your life. And to understand why your body still runs it, you have to go back to the animals that used to hunt us. For most of the last century, science popularized a very simple idea about how humans respond to danger. You've probably heard it, the fight or flight response. The idea is that when faced with a threat, your nervous system pumps you full of adrenaline and forces you to make one of two choices: attack the danger or run away from it as fast as you can. But modern evolutionary biology has shown that fight or flight is an incomplete picture. It misses the very first step, the oldest step, the step your body almost always tries before doing anything else: freeze. To understand why freezing is so important, you have to look at how predators see the world. For hundreds of thousands of years, your ancestors shared the landscape with large carnivores: leopards, lions, wolves, bears, and massive birds of prey. These predators were faster than early humans. They were stronger, they had better night vision, but many of them shared one specific visual flaw. They hunted by motion detection. The visual cortex of a big cat or a wolf is exquisitely tuned to detect movement against a background. A running human is a glaring, unmistakable signal that says prey. But a human standing completely motionless, especially in dim light or among trees, often disappears into the visual noise of the environment. When a predator's brain is scanning for movement, stillness is effectively invisibility. Your ancestors who ran immediately when they heard a twig snap in the dark were often the ones who triggered the predator's chase instinct. They became visible. The ancestors who instinctively froze the moment they sensed danger gave themselves a split second of invisibility, and that split second was often the difference between living and dying. You are the descendant of the ones who froze, and your body has never forgotten how to do it. Which brings us to what is actually happening inside your brain when you lock up. When you freeze, you are not shutting down. You are doing the exact opposite. When your brain detects a sudden, ambiguous threat, it activates a tiny, ancient region in the brainstem called the Periaqueductal Gray. This region is so old that it exists in almost every mammal, reptile, and bird on Earth. When the Periaqueductal Gray fires, it essentially overrides your conscious motor cortex. It physically jams the brakes on your body. But while your muscles are locked, your brain is doing something incredible. It is running a high-speed data acquisition protocol. During a freeze, your pupils dilate to take in more light. Your hearing becomes hyperacute. Your heart rate actually spikes, pumping blood to your muscles so they are primed and ready. Your breathing stops or becomes very shallow so you don't make a sound. You are not paralyzed. You are a coiled spring. Your brain has frozen your body specifically so it can gather as much information as possible without giving away your position. It is rapidly calculating the threat. Where is it? How fast is it moving? What is the escape route? Should I fight or should I run? In the modern world, this calculation feels like panic. In the ancestral world, it was the necessary pause before action. But there is a second kind of freezing that happens when the threat is much closer, when escape is impossible. And this is the one that leaves people feeling the most ashamed. In the late 1990s, Dr. Porges introduced the Polyvagal theory. which completely changed how psychologists understand trauma and extreme fear. Porges identified that when a threat is overwhelming, when a predator has already caught you, or when a modern human is trapped in an inescapable situation, the nervous system deploys its final, most extreme defense. It's called the dorsal vagal shutdown, or tonic immobility. Your heart rate plummets, your blood pressure drops, your muscles go slack, your perception of pain is blunted. You may feel disconnected from your own body, as if you are floating or watching the event happen to someone else. In human terms, we call it dissociation, or going numb. In animal terms, it's called playing dead. When an opossum goes limp in the jaws of a dog, or a rabbit goes floppy when caught by a fox, they are not making a conscious choice. Their nervous system has taken over. And the evolutionary reason for this is profoundly dark, but incredibly effective. Many predators are triggered by the struggle of their prey. The fight is what keeps their killing instinct active. When prey suddenly goes completely limp, predators often loosen their grip. They assume the kill is complete. They may drag the body to a different spot or loosen their jaws to rest. In that momentary loosening, the prey sometimes gets a single, tiny window of opportunity to escape. Tonic immobility is not giving up. It is a biological Hail Mary pass. It is your nervous system playing the very last card it has, dropping your heart rate and numbing your pain, waiting for the predator to make a mistake. Which brings us back to the modern world, and to the shame. Millions of people carry deep guilt about how they responded during a car accident, a physical assault, a natural disaster, or a sudden crisis. They replay the memory for years, asking themselves the same agonizing question. Why didn't I fight back? Why didn't I run? Why did I just stand there? If you have ever asked yourself that question, you need to understand what science is now definitively saying. You did not fail. You were not weak. Your conscious mind did not choose to freeze. Your nervous system made an executive decision. It evaluated the threat, calculated the odds, and deployed an ancient survival protocol that kept your species alive for 300,000 years. It took control away from you because it believed, based on millions of years of evolutionary data, that freezing was the safest possible thing you could do in that exact millisecond. Your body didn't betray you. It was trying to save you. The environments we live in have changed drastically. The threats we face today are mostly speeding cars, failing machinery, social conflicts, and human violence. Our ancient programming doesn't always map perfectly onto modern dangers. Freezing in front of a speeding truck is not helpful, but the mechanism that causes it is not a flaw in your character. It is a testament to what it took to keep your ancestors alive. So the next time you find yourself freezing when someone drops a glass, or a car swerves near you, or a loud noise echoes down a hallway, don't be angry at yourself for stopping. Don't call yourself a coward. Just notice what your body is doing. Your muscles are tight. Your eyes are wide. Your ears are listening. You are standing perfectly still. You are invisible in the tall grass. And you are exactly what a survivor is supposed to look like.